Okay, so today I'm going to talk about the pigeonhole principle, which is a simple concept that helps you solve larger problems. So the pigeonhole principle is as follows. Let's say you have n holes and more than n pigeons. Then there must be some hole that has at least 2 pigeons in it. So as I write that, I want you to think about that for a second and raise your hand if you agree with that statement. So, given n holes, more than n pigeons, there exists a hole with at least 2 pigeons in it. Okay, raise your hand if you agree with this statement. Okay, we get like half agreement here. So I'm going to prove it for you.
Hey, Shelly.
Can I explain?
Yeah.
What is the backward E? What is it?
Sorry, this is that there exists.
No.
Okay, yes?
What if all the pigeons are in one hole? Then there's a hole.
Then that's a hole and it has at least 2 pigeons in it.
Oh.
But what
Mm-hmm.
if there's any pigeons that aren't in holes?
Oh, I'm sorry. You're absolutely right. So given n holes, n pigeons, each pigeon is in exactly 1 hole. That should have been specified. I apologize.
Okay, cool.
Okay, so you've got all pigeons are in some hole. Mm-hmm. Okay, so proof. We're going to prove this by contradiction. So assume not. So what's the opposite of this statement? If there isn't a hole with at least 2 pigeons in it, then that means that every single hole must have at most 1 pigeon in it. So it has to have either 0 or 1 pigeons in it, correct?
Can you say that? Sorry, can you say that again?
So if this statement is false, meaning that there is not a hole with at least 2 pigeons in it, that means that every hole has at most 1 pigeon in it. So it either has 0 or 1 pigeons, okay? So in that case, how many pigeons can we possibly have? We've got n holes and 0 or 1 pigeons per each hole. So the most number of pigeons that can possibly exist are n pigeons. But we have bigger than n pigeons, so that's not possible. So therefore, we assumed that the statement wasn't true. Then we showed that we had a contradiction in our assumptions. And so therefore, the statement has to be true. So, pigeonhole principle proof. Now raise your hand if you're convinced that the pigeonhole principle is false. Good. Okay. So let's do an example. Let's say I have 5 shirts, and they might be either white, gray, or black. So can I conclude that I have at least 1 white shirt? Yes or no?
No.
Who says yes? Good. No, you cannot conclude that, because they might all be black, for example. Okay. So can I conclude that I have exactly 2 shirts of some color? No, very good, because I could have 1, 3, and 1. Can I conclude that I have at least 2 shirts of some color?
Yes.
Yes, because that's the pigeonhole principle. So when you want to apply this principle to solving a complicated problem, it takes sort of 3 aspects. First of all, you need to recognize that it's a problem that you would want to use the pigeonhole principle to solve. Secondly, you have to figure out what are the pigeons, and then you have to figure out what are the holes. So let's do an example. I claim that there are at least 2 powers of 2 which differ by a multiple of, say, 2012. Okay? So here's the statement. Do you have 30? All right. So there exists, this is a symbol for there exists, say 2 distinct powers of 2. That means, say, 2 to the 5 or 2 to the 7 or something like this, whose difference, so 2 to the x minus 2 to the y,